another video in this week's Java data structure tutorials. So last video, I kind of got you guys started with heaps, talked about how they related in Java to the priority queue, showed you some visual representations, and kind of refreshed your memory on how we create a priority queue. Right, so in this video, we're going to be going ahead and creating some minimum and maximum heaps. Why is this so zoomed out? There you go. Let's zoom it to 100, but then that'd be too big. Okay, so we'll just zoom it to here. So we're going to be creating a priority queue minimum heap and a priority queue maximum heap. Now, last video, I showed you guys this picture of the minimum and maximum heap. And so if we take a look at this knowledge and we take a look at how our computer is going to store this, we know that our minimum heap and maximum heap actually are not going to be that hard to make. So take a picture of these two heaps in your brain right now. And remember that minimum heap means that your numbers are ascending and maximum heap means that your numbers are descending. And let's go ahead and talk about our minimum heap first. So minimum heap is a heap where the top node or element is always less than the ones below it. So the top node or element is always less than its child nodes. Okay, so that is a minimum heap. So you go from minimum to maximum. However, before we ended the video last time, when we were talking about just creating our regular priority queue and I ran it, does everybody see the order changed? In my priority queue heap here, I added in 10, 90, 50, and 5. However, when I printed it out, it gave me 5, 10, 50, and 90. Isn't this already in ascending order? Right? Our our priority queue already ordered it to be in the way of a minimum queue. So guys, I have some really nice news for all of you. Our priority queue minimum heap is already in the natural order because the default order for items is in ascending order. So the only thing we have to do now is to print out the items one by one to have a minimum heap. Now, we are not going to do this the standard way because I'm going to use the pull method and a while loop to do it. And so reason being, you're going to see in a second that it has to do with the way these values are stored. I'm going to use the pull method. If you don't remember what that is, it's when we delete the last value. So it's going to take the value and delete it. You might be confused on why I'm deleting my values. Well, that's because I don't want to keep my value in the heap because then I don't want it to necessarily go from left to right, because when you're going in ascending and descending order, left to right, node-wise, is incorrect, right? Because ascending order means I just want the numbers to go from smaller to larger, and I don't care about the parent and child nodes. So I don't want it to go from here and then zigzag all the way across because then my order will be messed up. So that is why I'm using the pull method. So that was a lot, but let's go ahead and try it. Hopefully this logic will make sense. So I'm just going to use a while loop. I'm going to say while, and then I have to give a condition. And so while that condition is true, we are going to print out the value that we are about to delete. So remember, if I say pqheap.pull, it's going to, well, delete my top value, but at the same time, when I print it out, it's going to get printed out to the console. But however, I do want to make sure that this happens forever and ever until our heap no longer has any values. So how I do that is I say while pqheap.size does not equal 0. So hopefully everybody knows what this means. Exclamation mark equals means not equals. So as long as the size of my heap does not equal 0, continue to print out the top value and delete it after you print it out. Okay, so run your code really quickly like this, and we're going to see that we get like this. This was the array format, but then to use a minimum queue method, we printed out 5, 10, 50, and 90. So everything looks good for our minimum queue, and we didn't even have to do that much work. Why? Because priority queue natural order by default is to put it in ascending order. However, if I try to go and print out my PQ heap again, you're going to notice that there actually is going to be nothing left, right? Do you see how we have a set of empty brackets right here? That's because we don't really have anything left in our heap. So while I do understand this is kind of upsetting, this is the way we're going to stick with right now, because in our current level of understanding for heaps, that's as far as we're going to go. If we do get to more advanced heaps next week, I haven't decided yet, or if we decide to move on, we may get to see how to use a function to do this faster. But for now, we're just going to keep it as an empty heap when we're done with it. Okay, so I cannot stress more over here. How do I stress this? That min heap, you don't have to do anything, because the natural order for priority queue, oh my goodness gracious, queue is in ascending order. Hopefully that makes sense. So you don't have to do anything because priority queue already did all of it for you. So minimum heap is pretty easy, right? Easy peasy. The next one that we're going to talk about, which is a little bit harder, but really, guys, not that hard at all, it's going to be our maximum heap. Okay, so this maximum heap over here, I have an iterator in my picture. I don't really like it. I'm not going to be using that. I'm actually going to be using still the while loop and the poll method. But we have a very crucial step here. So we know, guys, that minimum heap is in ascending order. So that means maximum heap is a heap where the top node or element is always going to be greater than the ones below it. So the top node or element is always greater than the ones below it, meaning that it goes from maximum to minimum. So now it is in descending order. So if we know that it's in descending order, we are going to have to change our priority queue somehow, right? Because it's currently in ascending order. So we use the collections.reverse order method to change, and we're going to put that actually in our priority queue area right when we create it. So if you can look at the picture here, right as soon as we create it, we put that function in, and then we add it as normal, and then we can print it out as normal, right? We just print it out using our while loop. So we do have to delete the items once we print them out, or else the order will get messed up. We talked about that last class, how we didn't want, not last class, a couple minutes ago, how we didn't want it to go zigzag left to right because that would mess up the order. And then we'll talk about this advanced part in a second. So let's go ahead and start fixing this up a little bit. We're going to say collections.reverse order. And I just forgot if there was a, it's not collections, it's comparator, right? It's not collections. I just blanked on that. It is collections. Okay, so it's collections.reverse order, and we're going to save it like this. So I think you can guess from reverse order, this is going to switch it. So instead of saving your numbers in ascending order, this part is going to make it save your numbers in descending order. So basically, guys, you've just switched everything, right? So now I'm not going to change anything. So I just left everything else the same. But if I run my code, tell me what you guys think is going to happen. Well, it gives us 90, 10, 55, and then it prints it out one by one. But since we pulled them, we deleted them. After we do that, it's an empty bracket. So this is good, right? Because we just created a maximum heap simply by playing around, manipulating our priority queue to just do all the work for us with, how many letters is this? Probably around like 20 letters, right? So maximum, minimum heap, while the idea concept, you may think that flipping everything around is hard, we didn't do much, because for minimum heap, priority queue did everything. For maximum heap, we just had to reverse everything. There was nothing particularly special about either one of them, right? In order to print it out one by one, I don't want to keep it in my array format because that is never the best way to go. I used a while loop. Okay, so that was minimum and maximum heaps. I did talk about advanced. I made a note here because since poll removes all the items from your heap, if you really wanted to, you could create a function for these 4 lines of code where you add numbers to your heap. You could create a function from that. That way, every time you can just run the function so that your heap automatically has new numbers in it. But that is something for you to think about, and it's a little advanced, but we talked about functions in our intermediate/intro courses, right? So with a little bit of thought, that maybe might come to you. Okay, so just to sum it up, minimum, maximum heaps. Minimum is in ascending order, maximum is in descending order. We always use the pull method because we want the order to be ascending, descending. We don't want it to bounce back and forth between left and right nodes. That's why we use the pull method. What else do I need to clarify? And the thought process itself is simple and easy because PriorityQueue honestly does most of the work for us. So guys, that is our video for this week. I'm very excited to see you guys for next week's videos, which I'm going to keep as a surprise. So I will see you guys then. Bye, guys.